Introduction to quadratic functions. We're going to take a look at a set of data and then apply it to a graph and learn some additional vocabulary. We'll start with this table. After collecting data, Bagel World updated the data for the number of coffees, X, and bagels, f of x, sold at Bagel World, and it's shown in the table below. The first column says coffee X. So it says if -3 coffees are sold, that 9 bagels will be sold. If -2 coffees are sold, 4 bagels are sold. And then the table continues. 1a. Tell me the domain of the values included in the table. Well, the domain of the values is from -3 to +3. We would list those. The range are all the bagels, so the number of bagels. And I'm noticing that on bagels, the 9 occurs twice, 4 occurs twice, the 1 occurs twice, and the 0 only occurs one time. So I want to only list the numbers one time, and usually from smallest to largest. Number 2, write an equation to describe the relationship between the number of coffees and bagels sold. Well, this is a quadratic, and we'll see it for certain when we graph the function. This is the quadratic y equals x squared. But since it had used f of x, we're going to replace that y with f of x. Number 3, sketch a graph of the function. I'm going to take the table of values and plot those ordered pairs. -3 for x, +9 for y. -2 for x, +4 for y. -1 for x, +1 for y. The origin 0, 0, and then in the first quadrant, an reverse image of the second quadrant's ordered pairs. When we connect these points, we make what's called a parabola. It's a U shape. The bottom of our parabola is not a V, it's a curve. 3b. Does the function have a maximum or a minimum value? This is a minimum value. The bottom of the vertex is your minimum. If your parabola had opened down and the vertex was at the top, this is referred to as a maximum. But in our case, we have a minimum. Number 4, what are the viable values of x for the domain of this problem? Now really, in this table of values, it does not make sense to say that we sold -3 coffees. So the viable options are we either sold 0 coffees, 1, 2, or 3. So the viable values from the domain are 0, 1, 2, and 3. Very last question, what are the viable values of y for the range of this problem? Well, the viable values for y also are still 0, 1, 4, and 9. That means the range does not actually change when we're taking a look at the viable options.